So for this, recall that if f, g are differentiable, then f into g is also differentiable, and in fact integral of 1 or sorry, a to b, a to x ft dt is say kx is also a differentiable function. So on that line, let's proceed. So we are given that ft dt is equals to x fx minus x cube by 3. Okay, and also that f1 is 1 by 3. So we'll differentiate this whole equation, and so by Newton-Leibniz theorem, the derivative of this will simply become 3 times. So according to the theorem, the derivative is derivative of x fx, so that is 1 into 1 into f of x minus the derivative of 1 times f1. So f1 is, as 1 is obviously a constant, so its derivative becomes 0. So the derivative of this term simply is this. And then on the right hand side we have x derivative of x fx, that is fx plus x f prime x minus derivative of x cubed by 3 is x square. So that gives us that gives us 2fx minus x, or rather let's take this on this side and x square comes here, so we get x square equals to x f prime x minus 2fx. So we'll divide this whole thing by x cubed, which will give us f prime x by x square minus 2fx upon x cubed equals to 1 by x. So this was done so that we'll get an exact differential here, which in turn, so basically this is the derivative of fx by x squared, and this is equals to 1 by x. So integrating, we'll get fx upon x squared equals to ln x plus c. And we are given that f of 1 is 1 by 3. So, or rather, let's take this x square there. We'll get x square ln x plus cx square. So from this equation we get f of 1 is c, and f of 1 is 1 by 3, so that gives us that c is 1 by 3. So substituting that here, we get that fx is x square ln x plus x square by 3. So this is our fx, and what are we asked? We are asked the value of f of e. So substituting e here, we get e square ln of e is 1 plus e square by 3, which is 4e square by 3. So the answer is C. So after differentiating, the question was pretty standard and straightforward, and I think this should definitely be done in the first go.